Okay, so let's look at number 22A just for kicks in 5.2. Okay, so this says suppose you have y that solves ax, oops, not ax squared, what?
A y double prime.
A y double prime plus b y prime plus c y is 0?
Yeah.
Okay, so you have some spring, right? And you have some behavior for that spring. All right? Then they want you to consider z, which is y, but evaluated at x minus x naught instead of at x. Right? Okay, so I think my inclination at least is to assume that z and y probably act in pretty similar ways, right? So what they're asking is for you to check if if z also solves.
Z is just y, just like move to the left or right a little bit, right?
Yeah. Yeah, z is just a horizontal shift. Right? Okay, so to check if z solves, right, you'd like calculate z prime. What's z prime?
Just prime the y and then.
Okay, so you get y prime times x, y prime, let me rephrase that, y prime evaluated at x minus x naught times the derivative of x minus x naught, which is 1. So then when you do z double prime, you get same thing. Y double prime evaluated at x minus x naught times 1. Okay, and then you want to know if this solves. So you take this stuff and you jam it in there, right? And so you get a y double prime evaluated at x minus x naught plus b y prime evaluated at x minus x naught plus c y, and then y is evaluated at x minus x naught for it to be z, right?
Mm-hmm.
And you're like, huh? Maybe it's 0? But you're like, well, what the hell about the x naughts? Right? There's a bunch of x naughts in here. That's different. Right? So the question then is, when? When does a y double prime plus by plus cy, a y double prime plus by prime plus cy, when does that equal 0? For what x's?
When x equals x now?
When a doesn't equal 0. Or a fixed constant.
Yeah, so if a is a constant, right?
It's everything.
Then it always works. You see that? So when?
For all
X.
For all the x's. So who gives a hoot if you shift the x's? Right, because it's true for all the x's. Like, it doesn't matter if you shift left, still true.
Because wasn't there a rule that all second order constant coefficients are valid on infinity to infinity, right?
Yeah, the solutions to all the spring-like things, right? Constant coefficient, second order linear, homogeneous differential equations. Yeah, all the solutions are all valid from minus infinity to plus
They're
infinity.
just e's and sine and cosines, right?
So when on R, well, yeah, I just don't care if you shift R.
So you wouldn't hit this with algebra, you just like explain some stuff here.
Yeah, you're not going to do any
'Cause I
algebra.
couldn't
You're
find
just
any
going to say
algebra
like,
to- yeah.
yeah, this is still true. Right? Because it doesn't matter where you evaluate, because you're really evaluating on all of our. Even if this was only true on some interval, right? I would get a result that's true on a different interval. Right? I would just think, okay, so if I take x minus x naught, which way does that shift a function?
X depends. No?
It depends on the sign of x naught. Right? But what's it going to do to the interval? It's just going to shift it around too. right? So if this was valid on some interval from A to B, then this would be valid on some interval
A minus.
from like A hat to B hat, where A hat and B hat are functions of A and B and X naught. And you can figure out what the shift is if you want it. Cool?